Give me a wave if you don't want to say anything, okay? Or give me one of these. What the? Exactly. Sometimes I catch students, I'm like, okay, I think we need to go back over that because I see that funny face you're making. All right. This question, these ask for the parent function and then the new function to be graphed on the same graph. What would the parent function be for number 1? Yep. So the parent function is just the plain old absolute value graph. What are some points on that graph? Put in some values if you need to. 0, 0, 1, 1, 2, 2, 4, 4. They're counting by 2s. So I'll just do this. Everybody okay? Color is really nice on these, but I've also done it where I do like the parent function in dashed lines and the new function in solid line. I don't care. It just helps to see what the difference between the two. So what changed to g of x? It says describe. So what two things happened? Right. It is a horizontal shift of left 4. If you just wrote shift left 4, I would be okay with that. I am not picky about the horizontal vertical thing, okay? But it is left 4, which is horizontally. And what else happened? But since it is a half and it's affecting it vertically, it's actually going to compress it vertically, okay? It's on the outside of the whole function, so it is doing exactly what it seems, which is compressing. And if you said shrink, I'd be fine with that, okay? All right, so let's try to graph this thing. If we took the point 0, 0 and shifted it left 4, it would be at 0, negative 4. Does that part seem okay? Then the compressing vertically by 1/2, let's just put a couple points in and see what we think, okay? What do you want to put in? 1, did somebody say? Okay. If I put in a 1, I'd have 0.5 times 1 plus 4 would be 5. Half of 5 would be 2.5. So over 1, remember this weird graph paper, over 1 up 2.5 would be right about there. I don't know if that was a great choice. And it's absolute value, so it's going to do the same thing this way. That was kind of... How about 0? Can we put in a 0? Make me feel better. Put in a 0, we'd get out a what? 2. So here is 0, 2, and it went this way, it would be right here. Is that enough for us to graph it, since we're kind of in a hurry today? Does it look like Hofbauer sat on it and it got compressed by half? Okay. It would be a flat line if Hofbauer sat on it. I know. All right. What is this one, guys? What is the parent function on this one? Okay. Which goes through 0, 0, 2 what? If you square a 2, you get out a 4. It would go through 1, 1 as well, but those points don't fit on this weird graph paper as well. Okay. Yeah, not so much, but we'll go with it. All right. The two things that happen, what does the minus 4 do? And I'm just going to write down 4 because I'm kind of running out of room here. What does the 2 do? It's vertically up and down. Okay? It's a vertical stretch.
How would you be able to tell the difference for a quadratic?
If it said this, then I would want you to describe it as a horizontal compression, actually, yeah, which is the same as a vertical stretch on a parabola, so it's weird. All right, back to the graph. So I know this point has been shifted down 4. Let me use green here, right? Down 4. But then to find some more ordered pairs on the graph, can we just put something in? Why don't we put a 2 in since the graph is counting by 2's? What would 2 times 2 squared minus 4 be? 4 times 2 is 8, minus 4 would be a 4. So we put in a 2 and got out a 4. There's an ordered pair. It's way up here. So negative 2 is going to do the same thing. Yes? Everybody okay? Because it's a parabola, it's got symmetry. So do you see that it has been stretched so it's going up faster? See, from our original vertex, it went over to and up 4. This one, when it went over 2, it went up 8. Okay. Yes. Steeper relative slope. I like that. Anybody else have a question or comment? Okay, let's try this one real fast. Anybody remember what this parent function looks like? 0, 0. What are some other perfect squares? 4, 2. I don't even think 9, 3 would fit on the graph. It's just off the graph. 1, 1 is an ordered pair on there. I didn't draw that very well, but you get the idea. And this is a nice, easy one. What are the two things that happen? Remember, anything that happens inside here is kind of the opposite of what it seems. So it's left 3. So every single point we graphed should go left 3, up 1. Left 3, up 1. Left 3, up 1. Left 3, up 1. Well, it was off the graph. Yeah, it was supposed to be at 9. Yeah, and I didn't do it very good. It should be curving and then kind of flattening out. I didn't draw it very well. Everybody okay, though? That one wasn't too bad? Now, I know you can type these in your calculator. Does everybody know how to type them in their calculator? Look at the table and find some nice ordered pairs? Okay. That's a great question. On your calculator, if you wanted to type an absolute value, it is, anybody remember? I'm going to turn these off. I'm going to come back to them. Okay. It was on the last quiz and it was on the board for that quiz, but what you can do is it's under math, arrow to the right. This is a really important feature, guys. Look, absolute value is this first one, and it will bring up the little bars, or if you have an older calculator, it'll just say ABS, and then you want to close it when the other bar is. But back under that math, arrow to the right, I think I pointed this out yesterday. I'm not positive in this class. I get confused. But this int is the integer function, the greatest integer function. So this does the step 1, okay? That number 5 right there, if you wanted to graph that. All right. I'm going to come back to this calculator in a second. What I want to tell you real fast is it's possible on a test or quiz, I'm not going to give you an equation at all. I'm going to give you a picture. If this was the picture and it said to do this, could you do that to that picture? Whatever those ordered pairs were, you would do what to each one of them? Left 3 and up 1. Okay? But you couldn't type that in your calculator, right? You just have to understand what the transformations mean. All right, just saying. All right, I don't really like this question. I'm going to go kind of fast. If you plot the original absolute value, it would go through 0, 0, 1, 1, 2, 2, and negative 2, 2, and so on. I don't think I would ask this one on a test or quiz. Does anybody remember what the negative on the outside does? Yes. Reflects it over the x-axis. If that's all I did, it would look like this. Everybody okay? You don't need to draw that one necessarily, but do you understand what I'm saying? It would just flip it over. But this 2 inside, because it's inside, it is a horizontal shrink by 1/2. It makes things shrink down horizontally. So, again, just put some ordered pairs in, and then I'm going to talk about why this one just seems weird. Okay, if I put a number 1 in here, I multiply it by 2, that's 2. I take the opposite, though, and it becomes -2. So at 1, instead of being down at 1, it's at negative. What did I just do? Yes, I put in a 1, right? And it should be to -2. Can you tell that that is a horizontal shrink? No. What it really did was it pushed these sides in after it flipped it over. But you can't tell that. The reason you can't tell that, because this is absolutely equivalent to this. You could pull that 2 out of the absolute value. So a vertical stretch and a horizontal compression in this case are identical. Don't let that blow your mind too much. I'm not going to mess with that on a test or quiz. Okay, help me out here. Parent function is just an absolute value graph like this. Okay, there's our parent function. What 3 things need to happen? Left 2, stretch vertically by 2, and shift down 2. Down 3, sorry. All right. So I'm going to take this corner point, or this vertex point kind of here, and shift it what? Left 2 and down 3. Be careful, remember the graph paper counts by 2. So it would be at left 2, down 3 would be at -2, -3. And then to figure out the stretch, if you want, you could put in a point again. What do I get if I put in 0? 0 plus 2 would be 2, times 2 would be 4, minus 3 would be 1. So at 0, it's up at +1. Does it seem like it's stretched by 2? Okay. I did the shift first. I went left. So instead of at 0, 0 right here, we moved it left 2, which is 1 on this weird graph paper, and then down 3, which is a box and a half on this weird graph paper. So it's at -2, -3. And then I just found one more ordered pair. I put in a 0, got out a 1, and so it's symmetric on both sides. If you wanted to put in another ordered pair, like put in a 2. 2 plus 2 is 4, times 2 is 8, minus 3 is 5. So it would go through as well 2, 5 right up here. And so on this side, it would also be going through here, I think. You do a very good job. We okay? Okay, I'm going to come back to this one. Let's just do this one real fast. And I am going to go kind of fast because this is kind of just an evil graph that you would normally probably just do on a calculator. Can anybody find me 3 ordered pairs for this parent function? Or 4? 2, 8 is at the very top. 1, 1. 0, 0. Let's do a little more. -1. -1 and -2, -8. Would you have remembered that the cubic was that shape, I hope? Ooh.
Really hard to grab.
It was, and I did a pretty nice job, if I say so myself.
That was pretty good.
Okay, what's the shiftiness going on here? Okay, so the whole thing moved left 1. Yes. This is what it would have looked like normally, right? It shifted left 1. But this absolute value means that all the things below the x are reflected above, okay? Because it means no matter what I put in, I will get out a positive. So even though I go left 1, it's going to actually go up 1. That's this dot moved up here. This dot will flip all the way up to here. So it does look like a parabola, doesn't it? Okay. I want to show you on the calculator just because I want you to see that it is a little bit different than a parabola. What do you think is different about it? Parabola kind of does that, right? Here's the absolute value 1. I typed it in, and this is what it looks like with the absolute value. Okay, so is that what yours looks like on your paper? Kind of. Then it is a little bit flatter at the bottom, but if I typed it in with a squared and no absolute values, so this is, does everybody see that this would just be a parabola, right? The parabola actually goes up more slowly. Think about that. Shouldn't a cubic go up faster? Because you're cubing things, right? So that's kind of the difference. All right. The problems you needed to do on that were here, 7 through 13, and so on. Everybody okay? Now, what you're supposed to add tonight to that assignment are just these 4 questions. And I'm going to put this up here real quick. Okay, so on page 52 tonight, you need to add 32, 33, 35, and 37. These need to be nice, accurate graphs of piecewise functions. So therefore, up in the green bin at the front of the room is all kinds of graph paper. Help yourself. I don't care if you take 1 per problem, or you can probably, I fit them all on 1 sheet, but I don't care. Take 2, 3, 4 sheets of paper, okay? So you have some graph paper to do these on. All right, now I'm going to flip back and do the one on 7. Right, there was one on the bottom of 7. Was this worksheet 7 or not? Okay, worksheet 7, this guy right here. I don't really like this one, but here we go. Okay, if I just said I had y equals -1, I would get this line. Don't draw this line because you'll have to erase half of it. Oh, I did really bad that time. But does that look like y equals -1? But I only need to keep the piece that is from -3 and less. So at -3, I get -1, but because it's an or equal to, is it a solid or open dot? Okay, because of the or equal to, it's a solid dot at -3, -1. And then which way does this line go? Because it says less than -3, it goes to the left only, and I have to erase all of this. So draw that piece on your paper. Okay, -3, -1, and staying at -1 going to the left. Okay. Now, don't draw this until we decide on a finished product. But this is a line, yes? What do you know about that line? Okay, it crosses the y at 1 and goes up 1 by 1s, yes? But I want the piece that goes from -2 to +2. Some of you would want to do this, maybe -2, -1, 0, 1, 2. Now, the one at -2 doesn't have an equal to, so this is going to be an open circle. But it goes right up to -2, guys, so it is an open circle. Okay, don't have it stop early. And then at 2, you have a solid circle because of the or equal to. All right, the rule was to add 1, So what would I get if I added 1 here? Negative 2 plus 1 is negative 1, 0, 1, 2, 3. All right, so if I plotted those dots, I'd have negative 2, negative 1, but it's supposed to be an open circle. And then negative 1, 0, 0, 1, 1, 2, 2, 3. 2, 3 is supposed to be what kind of a circle? Solid, because of this or equal to. It said I could include this point right there. All right, this is connected, and I did a really crummy job of drawing that line. Okay, and this, uh-oh, what happened to my pen? Ah! Okay. Then from 4 to 6, now notice there was a gap in the graph over here, right? It jumped from negative 3 to negative 2. This jumps from 4 to 6. Okay, this is the piece I really detest, okay? Because from 4 to 6, it says to do this. What does this mean? It's the step function. It means the greatest integer function. It means round down. The definition is actually all integer values less than or equal to x. So, if I put in a 4, a 5, and a 6, okay, 4 less than or equal to, what's the greatest integer less than or equal to 4? 5? 6? Okay, but what if I put in some values in between? 4.5 less than or equal to that would be 4. 5.5 less than or equal to that would be, okay, so it starts at 4, 4 with a dot, and that goes all the way over to 5, but it's an open circle. Then it jumps up to 5, goes over to 6, and it's an open circle. Then it jumps up to 6 with a solid dot, and I'm supposed to stop. That's the part I would have gotten wrong. I would have done wrong. Okay? I either would have forgot the dot at 6, or I would have made the line going over. I'm not going to ask you one that tricky.
That's really messed up with like the graph. It's just not a normal graph. Those types of graphs
Yeah.
shouldn't exist.
Actually, this is kind of real world stuff, guys. This would be like, there's a lot of things in life that if you get a half of something, you have to round down, right? You can't have a half a person, or you can't have.
Well, you can't. Like, that would be uncomfortable.
Yeah. All right. So there are things that have to be rounded down or rounded up. We're going to do a couple more of these, and then we're going to do worksheet 9. Let's see if we can try. This is on worksheet what? Somebody tell me what worksheet this is. 8? Okay, I'm going to do this one, and I'm not going to like it. I'm telling you right now. All right. I wouldn't ask you this because these aren't graphs that we do a lot of. The first one is a line, yes. The second one is a cubic shape, which is like this, right? What is this one? Do you remember the parent function for 2 over x? Which is 1 over x. The parent function looks like, remember this guy? Okay. This is not one I would ever ask on a test or quiz. All right. On the test or quiz, I will stick with lines, absolute value, maybe, and a parabola. Those are probably the only 3 things I would put on there. And a constant, which is really a line, it's horizontal line. Okay. This is x minus 5, and it says for values less than 0 up to and including 0. Okay, guys? I think this is the way some of you would be better off, is just saying, okay, I can put a 0 in. After that, I have to put in numbers less than that. Does that work? Okay. If I put in a 0, 0 minus 5 is negative 5. If I put in a negative 1, I get a negative 6. I put in negative 2, I get negative 7. Okay, everything is good to the left of 0. Do I put a solid or open circle at 0? Because of the or equal to, this is going to be a solid dot. At 0, negative 5, which should make sense because it's a line that has an intercept of negative 5, right? Should be going up 1 and over 1, but I want to go to the left, so it actually goes down 1 and back 1, which are the two ordered pairs here. That seem all right so far? Would you've gotten that piece, maybe? Maybe. Okay. This cubic piece, okay, this cubic one, it says to go from 0 to 2. I'm going to write down 0, 1, 2, but do I include the 0? So this is going to be an open circle. And the 2, what about the 2 at the other end? It will be a solid circle. Okay, what is 0 cubed? 0 cubed is 0, 1 cubed is 1, 2 cubed is 8. So there's our ordered pairs. It has an open circle at 0, 0, a solid circle at 1, 1, and a solid circle at 2, 8. And it is just that little bit of a curve right there. All right, then I'm going to switch to green here and talk about this guy. This says from 2 on up, so what are some numbers we might try putting in there? 2, 3, 4. At 2, okay, it said to start at 2, but it didn't have an equal to, so this is going to be an open circle. Okay, the rule is 2 divided by that number. So 2 divided by 2 is, 2 divided by 3 is 0.7, it's 2/3. 2 divided by 4 is 1/2 or 0.5. Remember what it looked like, guys? This is what it looked like, yes? But we're starting at 2, 1. Solid or open, remember? Was open. At 3, it's at 0.7. At 4, it's at 0.5. At 10, it would be at 0.2. It just keeps getting closer and closer to there. And why did I put an arrow? Because it says x is greater than 2, right? Keeps going on and on and on. Okay, I don't like that one at all. Yes. Okay. This line underneath here, the fact that it's an or equal to, means when I put in 0, I will get a solid circle. This does not have a line under it. It was just x is greater than 0. So at 0, I will have an open circle on this one. At 2, because it had the or equal to line, I will get a solid circle when I put a 2 in. Better? All right, let's try this one. Then I want to get to the matching activity. All right, what is the first piece? X plus 6 squared is a what? It's a quadratic, it's a parabola. I want to put in values starting with -5 and going less than that. What's less than that? -6, -7, okay. And do I include the -5? So this should be an open circle. All right, if I put a -5 in, I add 6, I get 1, I square it, I get 1. Put a -6 in, I get a 0. Put a -7, add 6, I get -1, but -1 times -1 is 1. Let's try one more. -8 plus 6 is -2. What's -2 times -2? Okay, so -5, 1 is an open circle. -6, 0. -7, 1. -8, 4. And it should be a parabola, we said, and it should keep going because it says everything less than -5. Would you have gotten those points and figured out the shape? All right, the next is my favorite. Yep, it says everything from -5 to 2. I wouldn't even bother to write this down, but I'll pretend. All of those, right, from -5 to 2 are just what? What's the rule? The rule is 7. All right, so what about solid or dotted? Taysir, can you tell me? Yep, both ends are closed, right? So this is solid and this one is solid. So let's just draw a line that goes from -5, 7 over to positive, whoa, +2, 7. Okay. The next, oh, yeah, I did go a little far, didn't I? Sorry. The next one starts at 2 and goes greater. 2, 3, 4, 5. It's some kind of a V, yes? But it's kind of weird. It's switched around weird. So let's just plot the points. It's going to have an open circle at 2 because it says greater than 2. 4 minus absolute value. So put in a 2. 4 minus 2 is 2. Put in a 3 is 1. Put in a 4 is 0. But put in a 5, what happens? 4 minus 5 is -1, but the absolute value makes it 1. 4 minus 6 is -2. Absolute value makes it 2. We got to try to get that V shape out of this here. 2, 2 was an open circle. 3, 1. 4, 0, 5 back up to 1, 6 back up to 2. How'd we do? It actually shifted to the right, and I could go through explaining that, but let's just keep going. Let's just not. All right. Worksheet 9. Are we awake?
Yes.
You already had candy or cookies, right? We're going worksheet 9. Okay. We're going to have to go kind of quickly. This is all matching. This is the parent function. Are you glad I didn't make you graph that? Okay. So it had a line, it had a constant, it had a parabola, it had an absolute value, it had constant and a line. Line, constant, parabola, little bitty absolute value, line or constant, line. It's all there. You don't have to graph it. Okay? We are going to match these to the graphs. You are going to have to do this on a test or quiz. You're going to have matching questions with goofy graphs.
Like this crazy?
Not this crazy, no. But, and there's some of these are harder than I would ask. But this would be very helpful if you wrote this down, okay? And then we'll try to match these. We're going to run out of time eventually. But what does multiplying a 2 on the whole thing do? Vertical stretch by a factor of 2. This would be a vertical stretch of a factor of 3. Okay. Yeah, this was an F. Yeah, I blew it up and it's all nasty copy here. Sorry. All right. The 1/2 here would be a vertical shrink, but what does the negative do? The negative reflects the graph which way? Over? Yes. Sorry, that's really messy. Reflect over the x-axis and also a vertical shrink of 1/2. Okay, two things going on. This is an easy one. What's this one?
7 left.
Left 7. I'm going to skip around and do the easy ones. What's this one down here?
Reflection and
reflect over x,
And down.
and down 9. Let me call on somebody. Kirsten, do you know what this one does right here? Perfect. Right 5, down 6. Omar, do you know what this one does? Good job. Yep, you're right. All right. Now we got the weird, horrible, painful ones. Ready to try this? Inside is actually a horizontal, and inside is the opposite of what it seems. So multiplying by 2 actually shrinks the graph, or compresses, by 1/2, by the reciprocal of that, which would be by 1/2. And it shrinks it in towards the y-axis. It will change the x-intercepts. They will become half as much. This one is the same as f of 1/2 x. So this is a horizontal stretch by 2. It will stretch it out away from the y-axis. All right, I'm running out of room to write. I am going to go down here for this one. Do you remember what the absolute value did? This is a brand new one, never saw before this year. Okay, so there's nothing below the x-axis. It reflects the pieces that were down there up above the x. All right, this is the truly weird one. Anybody have their notes from yesterday? Remember what this one did? It cuts off the left of the y. And then it makes the graph have y-axis symmetry. So it reflects what was on the right back across. And this last one is one I would never ask you to do on a test or quiz. And because we're running out of time, matter of fact, I'm just going to cross it off altogether. We're going to have to cross off one of the graphs as we go through them, but that's okay. Everybody got what they want written down? Okay. This is what I want you to do. Right now, take your hands, put them over your head, shake them. Put your hands on your ears, rub your ears. Okay, literally increases blood flow to your ears so you listen better. Let's try to get through these last few. A. Okay. Here we go. This is the original function. This is the new one. They're not the same size, so it's a little hard to tell. But can you tell what changed? Did the x-intercepts change? These stayed the same, yes? Okay, so this used to go up to about 4, and now it's going up to about 8. What do you think? Yes, stretched by 2 is which one? No, it is not shifted down. This one used to go down. If it was shifted straight down, the intercepts would have changed. Okay, this used to go down to like -6, and now it goes down to like -12. Okay, was not shifted because the x-intercepts did not change. B, what's going on here? Okay, it is reflected over the x-axis. Everybody sees that it's been flipped over? Now, the two things that offer a flip over the x-axis are these two. Has it been shifted down? No, but this used to go up to 4 and down to 6, and now it's going only down to 2 and up to 3. Do you see where that's half? Okay, So it's negative 1/2 f of x. It's vertically compressed. All right, this is a pretty easy one. Okay, which absolute value happened? Is it have y-axis symmetry? Then it can't be that one. Okay, so they just took this that was down here, look down here, flipped it up here, yes? They took this weird thing that was down here, flipped it up here. Is that what it looks like? So that's one you have to know. Okay, what's going on here? This spot that used to be at 0, 0 is now over here, yes? This spot that used to be down here is now over here. So it definitely shifted left. 6, 7. The only choice is what? 7, this one? I don't know if it looks like 7 or not, but we're going with it. It's the best choice we have. It just shifted left. Okay, we're doing pretty good. Woo! What happened here? It has y-axis symmetry, I noticed right away. Did they cut this left side off? Yep, and then they made it y-axis symmetry. So they cut off the left and made it have y-axis symmetry, which is? Yeah, the absolute value is inside. You got to know the difference between those two. This means, guys, that the x's, that no matter what I put in for x, I get out the same y value. Does that make sense? If I put in a 2, and I go to the right 2 or the left 2, I'm going to have the same value. That's why it has symmetry. This is the one that I told you they cut off. It would be, this is the one to cut off because they did this. They flipped it over across the y and then they cut it off. So they flipped it over and yeah, we're skipping that one. Okay, what did they do here? Did the x-intercepts change? It used to be out here at like 12 and now it's at like 6, yes? So they did this. How can you tell they didn't stretch it horizontally up? Because is this still at the same spot? Yeah, the height of it? The height didn't change. The intercepts changed. They shrunk it in. What is that one? Shrink it in, yes, because shrink we would normally think half, but when it's inside it's the opposite. All right, this looks weird because it's cut off on the sides, but it's just because of the window. They stretched it out this way. Yes? So where it used to go through 6, now it's going through about 12. This is stretch horizontally. Remember, this does the opposite of what it seems. Stretch by 2. Then we got easy ones left. This is reflected upside down, but what else? Down 9. It's the only choice, right? And this is down, but also what? To the right. Do you see that it went to the right a little bit? What's that one? Down and right was... Is that the last one or not? We did it? You guys are amazing. Thank you for keeping up with me.
1 minute to